All right, guys, we are just about ready for another test. You have the long weekend to do some practice. So leading up to that, I wanted to walk you through each of our review problems for those of you that weren't here for the review, or if you just can't remember how to do one of these. So number one on the review, f of x equals negative x squared minus 4. Remember, that's just like y equals. Negative x squared minus 4, it wants us to graph it. You can plug in numbers and see which ones match the graph, or you can just put it in your calculator. Negative x squared minus 4. And when I hit graph, my zoom's a little bit funny, so I'm going to have to fix that. If I go zoom, probably standard. And when I look at this picture, I'm 1, 2, 3, 4 down. I'm at negative 4 right in the middle. So that's kind of what I'm going to look for on these graphs. I'm going to look for, obviously, it's not this one. That's not in the middle. This one's not in the middle. That one's not in the middle. This is the only one that even looks close, and it's at negative 1, negative 2, negative 3, negative 4. So your answer would be B. All right, so graph it in the calculator, look at the picture, and make sure that they match exactly. Number two, again, graph the parabola, identify the vertex. So y equals negative 2x squared. So I'm going to plug that in my calculator first. I'm going to plug in negative 2x squared. So remember, you can use your TI-84. If you don't have a TI-84, you should be doing this on Desmos. I'll write down the website for you in just a minute here. But I graph that, hit enter. We want to graph and look at the picture. And it goes right up to the origin, right up to 0, 0. So when I look at these options I have to choose from, first of all, this one goes right to 0, 0, the vertex, but it's pointed up, and mine is pointing down. So it's definitely not those two. And then when I look at these two graphs, over here at negative 5, I'm down about 1, 2, a little more. So this point right here is like negative 5, negative 2.5. When I look at my picture, negative 5 is clear over here. And at 2.5, I'm nowhere near my graph. So it's definitely not that one either. So this would be my best option. It also wants you to identify the vertex. So after you put in that answer, it wants to know, what is that vertex? And this one, well, this one's pretty easy. I can just look at the picture and see that it's 0, 0 is my vertex. If it's not, all right, number 3. Identify the domain and range. Remember, domain is all the x's. The range is all the y's that are possible. So in this function, negative 3x squared minus 4, I'm going to go ahead and plug it into my calculator first. I want to make sure that I know what this looks like. Negative 3x squared. And then it was what? I already forgot the problem. Minus 4. And I'm going to graph that. And when I graph, as far as my picture goes, my y values stop right here. They don't get any bigger. They're no bigger than that. So that's going to be my range. But first, looking at my domain, those are my x values. And as the graph goes to the left, it's going to keep going left, left, left forever. It's going to go right, right, right forever. So the answer to the first question, what is the domain? It's going to be anything. It's all real numbers, anything I want it to be. Okay. Then it's going to ask you for the range. I didn't copy and paste that question in here, but it's going to give you something similar and ask you, what are all the possible outputs? And when I look at that picture, y can be anything as long as it is less than, as long as it's lower than negative 1, negative 2, negative 3, negative 4. It cannot be bigger than that. So my y value has to be less than or equal to -4. And I'm done. Number 4, graph the function, identify the axis of symmetry in the vertex. So here's my function, x squared minus 2x plus 5. We're going to go ahead and plug that in because why not? So let's clear this out and do x squared minus 2x. I've got to look at this again, plus 5. And I'm going to go ahead and graph it so I kind of have an idea what this looks like. So the picture's not too bad. I know it faces up, but my vertex is right here somewhere. Ooh, maybe I should use a different color pencil. My vertex is right there. And when I look at my graph, it looks like it's up about 1, 2, 3, 4, and it looks like it's to the right about 1. So it looks like it's at about 1, 4. I can double check that. I can hit trace and I can follow this and look for my vertex, which is right here at about 1 and right here at about 4. So I'm pretty comfortable with that answer, that my vertex is going to be 1 over and up 4. My vertex is going to be right there. That's good information to know. I don't use that quite yet. Well, I guess we can graph it first, but I think it's going to ask you for the axis of symmetry before it will let you graph it. If it lets you graph it first, awesome. Do that first. Go ahead, and when you graph it, the first thing it wants is the vertex. So pick that point. And then it's also going to want another point on the graph. And to do that, I'm just going to go to my table and I'm going to pick a nice easy point. How about 0, 5? 0, 5 is an easy point to find. So I go over 0 and I go up 5, which is right here. Oops, 0, 5. And that, when I click on that, as I'm graphing it, it's going to give me my parabola. Okay. But it also wants the axis of symmetry. And some of you have been in here. When we were talking about the axis of symmetry, we talked about which axis it's symmetrical around. And it is symmetrical around the y-axis, but more specifically, I look at the vertex right here, and it's not just symmetrical around the y-axis. It is exactly symmetrical around this line right here. If I draw a line straight up and down through the vertex, the left side over here looks exactly like the right side. And it would help if I drew my graph a little bit better. But the left and the right look the same. So this is my axis of symmetry. And it's not just the y-axis, because the y-axis is this line. This line, we call it x equals, and we just look at the value of x on this line, because x is always equal to 1. It doesn't matter if I'm right here, or here, or here, or here, or here, or here. Wherever I am on that line, x is equal to 1. So my axis of symmetry is x equals 1. It wants an equation. So if it'll let you graph the picture first, go ahead and graph it. Then find your axis of symmetry, which, as long as you know this value, which you did because you graphed it, then you know the axis of symmetry. All right, number 5, solve the equation by finding square roots. So now we're solving, we're looking for when x is equal to 0, when it crosses that axis. And we talked, which number was it? There was another one that asked us to identify the vertex. And this right here, speaking out of turn here, the vertex isn't where we cross the axis. The vertex is that point where the graph changes direction. So even if it was shifted like this one, the vertex isn't here and here. Our vertex is that point right up there on top. But now we are solving, we're solving the equation. So we want to know when this graph crosses the x-axis. And it's set equal to 0, so it's already in standard form. And it wants us to use the square root method. You could use other methods, but it's giving you a hint that the square root method is the easiest one. And that's because there is no middle value. We have 3r squared minus 12. We don't have anything with irregular r's. So if I take 3r squared minus 12 equals 0, and I'm going to solve by using the square root, so I just have to get my square roots by themselves. So 3r squared equals 12. To get rid of 3, I divide by 3, divide by 3. So I get r squared equals 4. Now to get rid of the squared, I take the square root of both sides. So r equals 2. The square root of 4 is 2, but it also equals negative 2. That's something new this year. So our answers are r equals 2 and a negative 2. So right here in my box, I would put 2 comma negative 2. All right. Solve by using square roots. Again, it's giving you a hint. You can use any other method. You could use the quadratic formula, but square roots might be the easiest one. So x squared minus 100 equals 0. I add 100 to both sides. So x squared equals 100. And yeah, that hint was a nice one because this is definitely easiest because we're almost done already. We square root both sides. X equals the square root of 100, which is 10, but it's also negative 10. So x equals 10 and negative 10. So the square root method, you just have to get x by itself, which we can do when there's no middle value. If this had said x squared minus 10x minus 100, we would not be able to do the square root method because of that 10x. Okay, number 7. Solve the equation by finding square roots. So 4x squared minus 16 equals 0. Again, square roots, it thinks is the easiest way to do this one. So 4x squared, I don't have to do it this way, but I'm going to trust that it knows what it's talking about. I add 16 to both sides. 4x squared equals 16. Divide by 4, divide by 4. X squared equals 4. Square root both sides to get rid of x squared. X equals 2 and x equals negative 2. Because the square root of 4 is 2 and negative 2. So I put in 2 comma negative 2. And that's it for number 7. So those 3 problems, there's going to be 3 of them, I believe, on the test that say square root. I would use its recommendation. It's by far going to be the easiest method to solve these problems because you just railroad tracks, solve both sides, or solve for x, square root both sides. But some of these that we get to later, you might want to decide on a different method. But the square roots, I would stick with it. Find the value of h for the triangle. So it gives you a triangle, and it says that the area is equal to 19. And we know that one side is h, the other side is h. So the formula for the area of a triangle, remember, is length times width or height. I usually use height. Length times height divided by 2. Well, my length and my height are the same. It's h. So that's just h times h divided by 2, which is just h squared divided by 2. And we know that the area equals 19. So h squared divided by 2 equals 19. I'm going to do railroad tracks. Times both sides by 2, times by 2. H squared equals 38. And now I have to take the square root. So h equals, the square root of 38 isn't going to be a very nice number. When I square root, let's clear all this out of here. Second square root, 38, I get 6.164414003. So my answer technically is 6.1. All right, sorry about that. Had a teacher at the door. So getting back to the problem here, h equals 6.16441, 6441, blah, 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 blah. It's probably going to tell you something like round to the 10th on this problem. So h would equal not just positive 6.16441, but I'd round that to 6.2, but also negative 6.2. However, technically, h could equal both of these, but h is a distance on a triangle. So that answer doesn't really make sense. All I care about is the positive answer because h can't be a negative distance. It wouldn't make sense to say the length of the triangle is negative 6.2. So we're only going to have one answer. H is 6.2 positive. Okay. All right. Let's move on to number 9. Solve by factoring. If you like factoring, if you're good at factoring, go ahead and factor to solve. If you would rather put this in your calculator and try to find a solution where it crosses the x-axis, you can do it that way. If you would rather do the quadratic formula, you're more than welcome to do the quadratic formula. Solve by factoring, I'm going to solve it that way. I'm looking for something that multiplies to negative 36 and adds up to 5. So things that multiply to 36 are 6 and 6. Those aren't going to add up to 5. 12 and 3. Those aren't going to add up to 5. So how about 4 and 9? Now, this is a negative 36, so that means one of these is a negative, and they add up to a positive 5. So that means the negative is the smaller number, and negative 4 and 9 combine to make 5. So those are the two I'm interested in. Now, since there's nothing right here, I'm halfway done. I can just plug my factors in. P minus 4 times P plus 9 equals 0. Now, you're not done. We're looking for the solution. This is not a solution. This is simplified. This just helps us find the solution. Remember, these multiply to be 0. So either P minus 4 is 0 or P plus 9 is equal to 0. So I do railroad tracks, add 4, P is equal to 4. There's one of my solutions. And on this one, I do railroad tracks, minus 9, P is equal to a negative 9. So my answers are P equals 4, negative 9. And in the question, it might just have you put that part, the 4 and the negative 9. You can plug them in, check your work. If I plug in a 4 squared is 16, plus 4 times 5 is 20, minus 36 equals 0. Those add up to 36, minus 36 equals 0. So that is a correct answer. 4 is correct. I can do the same thing with negative 9. Negative 9 squared is 81. I add 5 times negative 9, which is negative 45 equals minus 36 equals 0. Negative 45 minus 36, that becomes 81. Minus 81 equals 0, which is true. So those are my correct answers. Okay, number 10, again, solve by factoring. I imagine a number of you are not going to want to do this one by factoring because of that 3. That scares some of you away. So one option is to put it in the calculator and see if your x-intercepts are nice. So we've got 3m squared. I'm going to change that to be, I can't do m, but I can do 3x squared. And then I have to, what came next? Minus 16m, minus 16x, and then minus 35. And when I graph it, I'm looking for where my graph crosses the x-axis, which there's one of them, there's the other one. And looking at the picture, this number, that's not a very nice number. This one might be. That one might be okay, but this one over here, that's not a very nice number. So graphing's probably not going to work. I'm going to have to use the quadratic formula. So you can do the quadratic formula on this problem. I'm not going to. I'm going to go ahead and factor because we're going to practice the quadratic formula later. But you can use the quadratic formula. To factor, remember we multiply those two numbers together, so that becomes a negative 105. So I'm looking for what multiplies to 105 and adds up to 16. 5 and 21 multiply to 105. And I think those are going to be the ones I want. Because it's a negative 16, my bigger number is the negative. And negative 21 plus 5 equals negative 16. So I can't just plug these into parentheses because of that 3. So I rewrite this 3m squared minus 21m plus 5m minus 35 equals 0. Remember, I just plug these into the middle. And then I'm looking for the greatest common factors. I'm splitting it in half and pulling them out. 3m comes out of this side, so I'm left with m minus 7. And over here, I can pull out a 5, and I'm left with m minus 7 equals 0. So the first step of my solution, m minus 7, is one of the parentheses. My other parenthesis is what's left over, 3m plus 5. Those equal 0 when I multiply them, which means one of them needs to be 0. So m minus 7 needs to be 0, or 3m plus 5 needs to be 0. Railroad tracks, add 7, m equals 7. And there's one of your solutions. M can be 7. And my other one, minus 5 from this side, 5 from this side. So 3m equals negative 5. Divide by 3, m equals negative 5/3. That answer is great. You do not have to change it to a decimal. In fact, it's going to be a repeating 3 decimal. So I would leave it just like this. And that looks correct. Negative 5/3, that's not quite negative 2, but it's closer to negative 2 than negative 1. So that looks like negative 5/3. And then my other answer was 1, 2, 3, 4, 5, 6, right at 7. So those two answers make sense to me. I'm not going to plug them in here because when I look at the graph, those two answers make sense, and I'm going to trust my math. All right, number 11, solve the equation. X plus 2 times x minus 8 equals 0. Please don't FOIL, because this is already in the form that we want. We know that these two multiply to be 0. That means either this one is 0 or this one can be 0. So x plus 2 can be 0, or x minus 8 can be 0. So if I do railroad tracks, minus 2, x equals negative 2. Railroad tracks over here, plus 8, x equals 8. So my solution set, the computer is going to give me my fancy bracket, and it wants my solution set, which is negative 2, 8. And then the computer should give you the bracket at the end. You're just plugging in the middle. So remember, set each parenthesis equal to 0, solve for x, and we know what x should be in order to equal 0. Solve by the quadratic formula and simplify. All right, so now we get into the long ones. It's already in standard form. It already equals 0, so that step's done. My a is 6, my b is 1, my c is negative 5. Be careful of the signs. And I plug that into the quadratic formula. X equals negative b, which is 1, plus minus square root. And I'm going to put all of my, everything I plug in, I'm going to put in parentheses because, well, it's just going to make our problem a lot easier. And if I put it in my calculator, I won't forget. So even though 1 squared doesn't need the parentheses, I'm going to use them. I'm going to try and stay in that habit. Minus 4 times a times c. So minus 4 times 6 times negative 5. Again, I put all of those in parentheses. And all of that is divided by 2 times a, which is 2 times 6. So I simplify. Negative 1 plus minus square root. This whole thing right here, the discriminant, you can plug right into your calculator. You just need to make sure to do the parentheses in the right place. So I can just go to my calculator and I can make it look exactly the same. 1 in parentheses squared minus 4 parentheses 6 close parenthesis, and then C was what? I forgot. -5. -5 in parentheses. And as long as I put the parentheses and hit enter, it's going to solve it for me. The underneath the square root part is 121. So this part is 121, the mess. And then 2 times 6 on the bottom is 12. Well, this simplifies further. -1 plus or minus square root of 121. That's a nice number. That's 11. And I can divide that by 12. So now here's where I need to split this into 2 problems because of that plus and minus. -1 plus 11 divided by 12. And -1 minus 11 divided by 12. -1 plus 11 equals positive 10 divided by 12, which simplifies to 5 over 6. That's a great answer. This one becomes -12 over 12, which simplifies to -1, which is also a pretty good answer. I can plug them in and check my work, or I can hurry and graph this and see if those look correct. So let's maybe try that way. Let's go to y equals, and we will change this to 6x squared plus x, because I believe we only had 1, right? Plus x minus 5, And when I graph that, I'm hoping that I cross the x-axis at about 5/6 and at about -1. Well, there's my -1. That one was pretty easy to see. So that answer is correct. And then this one looks like it crosses just a little bit to the left of 1, which is at about 5/6. So I feel pretty good about those answers. I'm not going to plug them in. I think that those are correct. Okay, number 13. Simplify the expression. Here's our imaginary numbers showing up. We're just going to treat them as if they're a variable for a minute. We're just going to FOIL. 4 times 9 is 36. 4 times -6i is -24i. And then I need to do my I times 9, which is positive 9i. And then I times -6i squared is -6i squared. Sorry, -6i. I times -6i becomes -6i squared. Now I combine like terms. 36. -24i plus 9 is -15i. And then my -6i squared, here's where we need to do a little bit more simplifying, because I squared, remember, I squared equals the square root of -1 times the square root of -1. And if I multiply the square root of the same number, then I get -1. So this I squared becomes -1. So -6 times -1 is actually a positive 6. So if I have a positive 6 and 36, I can combine those to be 42 minus 15i. When you simplify 2 complex numbers being multiplied, your answer should be a complex number. I squared shouldn't be part of your answer. Okay. Number 14. Simplify the following number by using the imaginary number I. So square root of -98. That becomes the square root of -1 times 98. And I'm assuming, because I'm in 10th grade and I'm not in 7th grade anymore, it wants me to find what this can kind of break down to. Square root -1 times 48 is actually 49 times 2. So I'm just taking this part and I'm kind of factoring it a little bit. -1 times 49 times 2 is still -98. So this becomes the square root of -1 times the square root of 49 times the square root of 2. And I know that this part is I. This part, square root of 49, is 7. Square root of 2, I don't know. So I'm going to leave that square root of 2. So when I rewrite my answer, I like to put my whole numbers first, then my square root, 7 square root 2, and then my I at the end, times I. Please don't accidentally put the I underneath the square root. It's not underneath the square root anymore. It's out in front. If you like doing I 7 root 2, either of those are the correct answer. Okay? All right, 15. Use the quadratic formula to solve the equation. I kind of have a feeling this one might end up needing some imaginary numbers, but let's see what happens. It's already in standard form. It's equal to 0. So A equals 1, B equals -6, C equals 6. And I'm going to plug those in. X equals -b, which is a -6, plus or minus the square root of b, -6, squared minus 4 times a times c. Again, I put everything in parentheses that I plugged in to my formula. And all of that is divided by 2 times a, which is 2 times 1. So when I simplify, -6 becomes a +6, plus or minus square root. -6 squared minus 4 times 1 times 6. I can go ahead and just plug that in my calculator if I want, as long as I remember the parentheses. -6, parentheses, squared. Nope, not to the -1. Delete that. -6 squared minus 4 times a, which was 1, times c, which was 6, right? 4 times 1 times 6. Plug that in your calculator just like it looks and hit enter, and you get 12. So when I go back to my answer right here, I get a 12, and that's because this becomes 36 and this becomes 24. So I get 12 divided by 2 times 1, which is 2. I don't know the square root of 12. So depending on how it wants my answer, I'm going to simplify this a little bit more. This becomes 6 plus minus the square root. I'm kind of looking for factors of 12 that I know the square root of. And I know that 12 is actually 4 times 3. And all of that is divided by 2. And because what I want to do is take the square root of parts of these. And I can take the square root of 4. So 6 plus minus. The square root of 4 is 2 square root 3, because I still have the square root of 3. I remember I pulled the 4 out, and that's a big 2, not a little 2 up on top of the square root. It's in front, divided by 2. So now I get 6 plus 2 square root 3, all divided by 2, and 6 minus 2 square root 3, all divided by 2. I can't add these two together very well. I'm not going to, well, I can. I'm just going to get an ugly decimal. So I'm going to get two answers. I'm going to get a decimal, and I'm going to get an answer with a radical in it, because if the problem says it wants it in radical form, and maybe we should check really quick. Let's go down here to test number 2. Or not test. What are we doing? We're doing the review. So let's do review, preview. And I want to go to number 15. And it says, simplify your answer including radicals. Use integers or fractions. Or in other words, I cannot get the decimal. When I do this math in my calculator, I'm going to get a decimal. It does not want the decimal. What I can do, though, is 6 divides by 2 and 2 divides by 2. 6 divided by 2 is 3. 2 divided by 2 is 1 square root 3, which is just 3 plus the square root of 3 is one of my answers. Over here, 6 divides by 2, and that's 3. Negative 2 divides by 2 to be negative 1, and I'm left with the square root 3. Whoops, there's no more fraction. And that just becomes 3 minus square root 3. So those are my two solutions, 3 plus the square root of 3, 3 minus the square root of 3. Do not get the decimal. It says that it wants an exact answer, and it wants you to use radicals. And that right there is a great answer. Okay, 16. Solve the following quadratic equation, x squared plus 4x plus 13. Factoring doesn't look too simple because what multiplies to 13 and adds up to 4? One of those is probably going to be a fraction. It has to be. So I'm going to go ahead and use the quadratic formula. And I get a equals 1, b equals 4, c equals 13. Are you sick of seeing the quadratic formula yet? X equals negative 4 plus minus the square root of 4 in parentheses squared minus 4 times 1 times c, 13. All of that is divided by 2 times 1. So that simplifies negative 4 plus minus square root. 4 squared is 16 minus 4 times 1 times 13 is going to be, let's see, 4 times 13 is 52. And all of that is divided by 1 or by 2. Negative 4 plus minus square root, that doesn't change. But I'm taking the square root of 16 minus 52, which is going to be a negative 36 divided by 2. And if I go back again to the assignment, I'm taking the square root of a negative number. That means because I'm doing that, there are no real solutions. But it might want imaginary solutions. So let's look at the problem. And it says on number 16, simplify your answer, include any radicals and I as needed. So it doesn't want us to just say there's no real solutions. It wants us to change this into an I. So negative 4 plus minus. Now, the square root of negative 36. Over to the side, I'm going to do this part because I get the square root of negative 36 becomes the square root of negative 1 times 36, which becomes the square root of negative 1 times the square root of 36. The square root of negative 1 is I. The square root of 36 is just 6. So this part right here, this square root of negative 36 turns into 6i. And then I divide that by 2. So from here, I split this up. Negative 4 plus 6i divided by 2. And negative 4 minus 6i divided by 2. I can't add these together because there's an I, like a variable, but I can divide by 2. Negative 4 divided by 2 is negative 2. 6 divided by 2 is 3. So this answer becomes negative 2 plus 3i. It's not a real solution. It's an imaginary one. This one, I can't subtract these because of the I, but I can divide. Negative 4 divided by 2 is negative 2. Negative 6 divided by 2 is negative 3. And I have I left over. So those are my answers. X equals negative 2 plus 3i, comma, negative 2 minus 3i. I also believe you could put this in your computer as negative 2 plus minus 3i. I'm pretty sure that plus minus button is one of the buttons on your answer. So when I click here to put in my answer, I have a plus minus right here. So I would put in negative 2 plus minus and then a 3. And then it also gives me my little I button right there. All right, moving on. Number 17, 3 more. State the vertex of the graph of the quadratic function. G of x equals x plus 9 squared plus 4. Remember, that just means y. And I'm looking for the vertex. So first of all, let's see what it looks like. X plus that, I mean, that's kind of new for some of you. In parentheses, I have x plus 9 being squared. And then I have to add 4. So let's go ahead and graph and see what that looks like. Oh, it's clear over here on the left a little bit. But if I trace it, maybe I can trace it without changing my screen. If I trace this, if I can get it over there. Come on, trace, come over here. See, my x's are at -6, so -1, 2, 3, 4, 5. So I'm right about here. So I'm almost there. I'm going to trace it, and I'm going to get myself right down to the vertex, which looks like it's at a -9 and 4. And if I go over this way, I'm just below -9 and above 4. So either way, I'm right at about -9, 4. So that's going to be my answer. My vertex, -9, 4. That's where it is. If you get numbers so that this may not show up on your graph, you might have to change your window. So maybe it would be easier if I put -20 as my minimum, and then I graph it, because I can see a little bit more of my picture. I just made it scoot further to the left. Okay. All right. Moving on, 2 more problems. Determine the discriminant of the quadratic equation. Use the value of the discriminant to determine whether the quadratic equation has 2 rational solutions, 2 irrational solutions. That means, we'll keep going. 1 repeated real solution, or 2 complex solutions that are not real. So when I take the discriminant, 4w squared, first I need to set this equal to 0. So -4w plus 14 equals 0. Remember, the discriminant is the part of the quadratic formula that's underneath the square root. So it's b squared minus 4ac. So b is -4, so -4 squared. And then I'm going to -4 times 4, and then I'm going to times it by 14. So -4 squared is 16, minus 4 times 4 is 16, 16 times 14, geez, I don't know. 16 times 14 is 224. So I'm going to subtract 224 from 16 and get -208. So I'm taking the square root of -208. And that means that I'm not going to have, because it's a negative, I have no real solutions. So rationals don't work. Irrationals aren't going to work. Repeated real isn't work. The only possible ones are 2 complex solutions that are not real. And that's it. That's your answer. 19. Solve the equation 2x squared minus 9x equals 35. Notice it doesn't tell you how to solve it. You can solve it however you want. But first, we've got to put it in standard form. So I have to minus 35, minus 35. So this becomes minus 35 equals 0. Looking at this, one way to do it is to factor. I could see what multiplies to be -70 and adds up to be -9. What do we have? 14 and 5 are probably going to be the ones, and it'll be a -14. So then I could plug those into the middle and replace it. This could be 2x squared minus 14x plus 5x minus 35 equals 0. I factor out the greatest common factor, so this becomes 2x times x minus 7. And over here, I factor out the 5, and I get x minus 7 equals 0. So x minus 7 is one of my parentheses. 2x plus 5 is one of my parentheses. So x minus 7 can be 0. So that means I add 7 to both sides, so x equals 7. Or 2x plus 5 equals 0. So I minus 5, 2x equals -5. Divide by 2, x equals -5 halves. So those are my 2 answers. Doing it that way. If you don't like factoring, then let's just do something else. Let's do the quadratic formula. It's still 2x squared minus 9x minus 35 equals 0. A equals 2, B equals -9, C equals -35. So I plug it in. X equals negative B, -9, plus or minus the square root of B squared, so -9 squared, minus 4 times A, which is 2, times C, which is -35. And all of that is divided by 2 times A, which is 2. So I simplify. X equals -9 becomes +9, plus or minus the square root. This big mess right here, again, remember, you can just plug it in your calculator. We're plugging in -9 squared, -9 in parentheses, squared. If you forget the parentheses, you're going to get it wrong. Minus 4 times A, which is 2. And then times by C, which was -35. So -35. When I hit enter, 361. That means that this right here is 361. All of that divided by 2 times 2, which is 4. Now, I think that square root of 361, let's see if we know if that's a nice number. Second square root, 361. Is that a nice number, please? Yes, it's 19. So this becomes 9 plus or minus square root of 361 is 19 divided by 4. So 9 plus 19 divided by 4, 9 minus 19 divided by 4. 9 plus 19 is 28 divided by 4 equals 7. That seems like a good answer. In fact, when we did this the other way, I think that was one of my answers. 9 minus 19 is -10 over 4, which is -5 halves, which I think was my other answer. So my solution set is 7, -5 halves. Either way works. Either way will get you to the solution. Graphing it on, trying to do it on your calculator, probably because of this fraction, that answer is not going to be an easy one to find. So these other methods are probably going to be the better methods. All right. So from here, I want you to go ahead and do review 2 on your own. I would recommend that if you need to, watch number 1 and then do number 1. Okay. Watch number 2, do number 2. And so forth. Work your way through the review. Remember, the test is on Monday. The test is on Monday, and you have to have 100% on the review. That's my only requirement for the test. I want you to have 100% on the review for the test. So good luck.